Okay, so we are going to start with matrices. The first three exercises are already over in matrices, right? So we're going to start with 2.4 actually. Um, so we will first see few sums based on exercise 2.4, and then we'll kind of pick up some sums from the exercise. So before starting with the sums, as I said, I also wanted to tell you, I will just quickly brush up. We'll just quickly go through all the basics of matrices. What do you mean by matrix? What are rows? What are columns? What is order of a matrix? Probably what is transpose? We'll go through all the basic things, and then we can start with the bigger examples. Okay. So I'll share the screen. Okay. So a matrix is nothing but a rectangular arrangement of elements, right? Elements can be anything, all right? I mean, numbers, alphabets, or numbers can be positive, negative, any real, complex, you can have anything in terms of a matrix. The of elements. So it is mainly got, as I say, rectangular. So just a rectangular ka sides hota hai, length and breadth. वैसे matrix has got rows and columns, right? They're made up of rows and columns. What are rows and what are columns? Rows are nothing but the horizontal ones. Columns are the vertical ones. Okay. Horizontal matlab aisa, sleeping, sleeping, sleeping. Vertical matlab is standing, standing, standing. So the columns are the numbers which are written in the vertical form, and the rows are the ones that are written in the horizontal form, or the sleeping lines. All right. And so after this, you have few types of matrices. Few matrices like a row matrix or a column matrix. अगर सिर्फ एक ही row होगा, for example, something like this 3, 2, -1, that is called as a row matrix. Sometimes you may have only one column, so that is called as a column matrix. Order of a matrix is nothing but is always written as m cross n, where n is nothing but number of rows and n is nothing but number of columns. Now suppose if I have a matrix like this, how many rows and how many columns do we have? Row means the horizontal ones, column means the vertical ones. How many horizontal ones? 1, 2, right? These are the two horizontal ones, so 2 rows cross. How many columns? 1, 2, right? So 2 rows and 2 columns. These two are the rows. These two are the columns. Okay. So what is the order? Order is nothing but 2 cross 2, m cross n. That is nothing but number of rows per number of columns. Now, how many number of elements will be there in that matrix? That is nothing but m into n. That is number of rows into number of columns का जो multiplication होगा. Suppose यहाँ पे 2 rows है और 2 columns है. So m into n is nothing but 2 into 2, which is equal to 4. So the matrix will have 4 elements. 1, 2, 3, 4. Right? 4 elements we have. Then of course you have a few types of metrics. So we'll do that as in when we come to those. Now let us start with multiplication of matrices is already done. Addition of matrices is already done. So I think we can now start with properties of a few transpose of a matrix. All right. So before that, you need to know what is transpose of a matrix. Transpose of a matrix is nothing but, suppose if I have a matrix something like this, A is like this, -1, 1. Chalo, we'll take the same upar wala example. Then if this is the matrix A transpose is denoted like this, A raised to capital T. Okay, so that's A transpose. Then A ka transpose is nothing but where the rows become columns and the columns become rows. That is what is called as transpose of a matrix. Suppose -2 और 1 यहाँ पे रो है ना, ये horizontal है, तो यहाँ पे vertical बन जाएगा. -2 and 1. Likewise, यहाँ पे 0 and 2 we have, that's a row, right? So that will become a column now. This is nothing but a transpose of a matrix. Likewise, if we have matrix like this. Suppose A is -3 1 0 2 5 4. Iska transpose again will be we doing it ulta, right? Rows are converting to columns, columns are converting to rows. So this row will become the first column, second row becomes second column, third row becomes third column. 5 and 4. Okay. Yes. Okay. So now um, let us start with a few properties of transpose of a matrix which may help you in solving problems. Properties of transpose of a matrix. Yes. Suppose if we have two matrices A and B, suppose. Okay. And A and B are of same order. Same order means ये 2 cross 3 है तो वो भी 2 cross 3 है. Likewise. Okay. अगर ये 3 cross 3 है A तो B भी 3 cross 3 का होना चाहिए. So that is what is called as order, as I said. Order is nothing but m cross n, number of rows को number of columns. If A and B are two matrices of same order, then this property will always hold. A plus B, the whole transpose, is equal to A transpose plus B transpose. Okay. A plus B, the whole transpose, will be equal to A transpose plus B transpose. So this is something you have to remember. 1 second. This is a property you're going to use, and you have to remember this one. Okay. Now the second one is, basically you have three. Okay. The second one is, if A is a matrix and K is a constant, then K times A transpose will be equal to K into A transpose. Okay. Please understand the difference between the previous one and this one. उधर A plus B था, where both were matrices. यहाँ पे A matrix है, but K is not a matrix, it's a constant, alright? Any number, constant is any number. So K into A transpose will be equal to K into A transpose only to A, not to K, okay? Because it's a constant, okay? You cannot have this transpose. Let me just highlight this. Now the next one, if A and B are conformable for the product AB, just a second. A into B transpose will be equal to B transpose into A transpose, okay? Yes, so this one will be ulta actually. This is the only thing where you have to be careful. A into B the whole transpose will be equal to B transpose into A transpose. Okay, addition में ऐसा नहीं होता है. Addition means the same thing. But anyways, even if you write B transpose plus A transpose, it doesn't make a difference. But यहाँ पे it is always ulta. A into B the whole transpose is B transpose into A transpose. If A and B are conformable for the product, that means conformable means, I mean, you cannot multiply any matrix like that, right? For multiplication also, for multiplying two matrices also, you have to see if those matrices, the two matrices are eligible for undergoing through the process of multiplication. Suppose if I have A as 3 cross 2, एक matrix है, और B है 3 cross 3. Can I multiply these two matrices? No, it is not possible, right? We can only multiply two matrices because these two numbers are not matching. They're not equal, right? We can only multiply two matrices. Suppose A is 3 cross 3 and B is 3 cross 2. Then we can multiply because the rows, the number of columns of the first matrix should always be equal to the number of rows of the second matrix. Okay, right now if you're talking A into B, apna first matrix is A, second matrix is B. So A ka number of columns should be equal to number of rows of B. Only then we can multiply. So right. So only those two matrices are eligible for undergoing through the process of multiplication. Then we can have this thing A into B. क्योंकि अगर multiply नहीं हो रहा तो उसका multiply करके transpose कैसे करेंगे? So that's not possible, right? So only if they are eligible वो multiply होने के लिए, then you can have A into B and then the following property holds. So these were the three major properties of this thing. So we are going to just take an example of this. So as I said, example, this is the same example that is given to you in the textbook. We'll prove, okay, A into B transpose is equal to B transpose into A transpose. Suppose A, I'm taking the same numbers like what we did, like how it is there in the textbook, 3, 1, 3. And B is like this, 2, 1, 1, 3, 2, 2. Okay. So what is the order of A? How many rows? 1, 2. 2 horizontals, 2 rows. 1, 2, 3. 3 vertical, 3 columns. 1, 2, 3. Here we have 3 rows and 1, 2, 2 columns. So yes, of course, the number of columns of the first matrix is equal to the number of rows of the second matrix. So yes, these two matrices can be multiplied. And the resultant matrix will be of this order. मतलब जो result है, answer है A into B का, uska answer will be, uska order will be 2 cross 2. So A into B is nothing but, we know that the resultant matrix is going to be of order 2 cross 2. So I'm giving only this much space. This will be this thing into this thing, right? First row into first column. First row of the first matrix into first row of the second column. So then now individual element wise multiplication. 1 into 2 is 2 plus 2 into 1 is 2 plus 1 into 1 is 1. Now the job of the first row with the first column is done. Come to the first row and second column. First row, second column, 1 into 3 is 3 plus 2 into 4 is 4 plus 1 into 2 is 2. The job of the first row with the columns of the second matrix is done. Now coming to the second row. Second row, first column. 3 2s are 6 plus 1 1s are 1 plus 3 into 1, 3. 3 3s are 9 plus 1 2s are 2 plus 3 2s are 6. Whatever answer you get, you're going to write it over here. 2 plus 2 plus 1, 5. That's 7 plus 2, 9. 9, 10, 11, 16, 17. Okay, so this is the final answer. This is your A into B. Now, yes, this is eligible for multiplication. So, multiply ho gaya. Now, we are actually proving this property, right? So, A into B transpose. Let us take. Now, this is your A into B. What will be A into B? Transpose. Transpose will be rows to columns and columns to rows, right? So, 5, 9 like this and 10 and 7. All right. So, now A into B transpose, this is actually your left hand side, correct? What do you want this equal to? You want this equal to B transpose into A transpose. So B we have, B का transpose we can easily find out. A we have, A का transpose we can easily find out. फिर उन दोनों को multiply करने का है. Alright? So B is this thing, we'll find इसका transpose and I'll write इसका transpose over here. So B transpose is nothing but 2, 3, 1, 2, 1, 2. And A transpose is nothing but 1, 2, 1. A में ऐसा था 1, 2, 1 ऐसा था, तो अब मैं ऐसे लिख रही हूँ. फिर 3, 1, 3 नीचे था सेकेंड रो में, तो मैं उसको सेकेंड कॉलम करके लिख रही हूँ. Now B transpose into A transpose. We're going to multiply these two. 2, 3, 1, 2, 1, 2. 1, 2, 1, 3, 1, 3. Now this row into this column, right? That is how we do. Abhi isko bhi you can just check if it can be multiplied. Of course, it can be multiplied. This is a 1, 2, 2 rows and 1, 3 columns. 1, 2, 3. Here 1, 2, 3, 3 rows and 2 columns. Of course, these two numbers are matching. So the resultant matrix will be of this order. So let us write B transpose into A transpose. What it is? First row into first column, right? 2 into 1, 2 plus 2 plus 1. First row into a second column. 2 3s are 6 plus 1 1 plus 1 3s are 3. 3 1s are 3 plus 2 2s are 4 plus 2 1s are 2. 3 3 9 plus 2 plus 6. So the final answer is 5, 10, 7, 9, 11, 17. Of course, this is your RHS. So every transpose पहले we got the LHS as 5, 10, 9, 17. यहाँ पे भी 5, 10, 9, 17. So therefore, we have proved that A into B transpose is equal to B transpose into A transpose. Now, just not like this property is going to work only for two matrices. In general, also you can have any number of matrices of satisfying this condition. So, suppose if we have A into B into C the whole transpose, uska answer will also always be ulta like this: C transpose into B transpose into A transpose. Okay, A B C D आया, तो D transpose into C transpose likewise. So you can have any number of matrices in general if you have A1, A2, A3, so on and so forth, till AN. And this is just a way of writing that you can have n number of matrices which will satisfy the same criteria. Alright, so that goes to A3 transpose, A2 transpose into A1 transpose. Alright, so that is how it works. Okay, now we will solve a few examples, a few properties with proof. Okay, so we'll also take examples. So we have statements and we'll also take examples like how we check this one, E transpose wala, because we'll check with the examples how those things work. Okay, now again coming to the next this thing, we know that there are many types of matrices, right? So उसमें से symmetric matrix is a type of matrix जहाँ पे उसका प्रॉपर्टी कैसे होता है, वो मैट्रिक्स का अगर ट्रांसपोज ले लिया तो दैट विल बी इक्वल टू द सेम मैट्रिक्स ओनली. जैसे मिरर इमेज होता है ना, उसको कभी कभी मिरर में लाइक यू नो like what a selfie, right? When you take a selfie or something like that, when you raise your right hand, उसमें लगता है कि you're raising your left hand. So it's like उल्टा. So that is not symmetric. Symmetric means उसका उल्टा वाला भी same to same होना चाहिए. So अभी this thing, for example, if I take like for any matrix, we'll prove the property only. A is a symmetric matrix, then A transpose is equal to A. Okay, uska transpose will be equal to the same matrix as I said. We'll take an example and see. Suppose let A is equal to 2 minus 3 4, 3 minus 3 5 minus 2 4 minus 2 1. This is of course a symmetric matrix, right? This is a symmetric matrix. So what happens in case of symmetric matrix? As I said, when you take a transpose, वो same to same वही matrix जैसा दिखता है. So अभी A यहाँ पे है. If we take its transpose, it should look like exactly this matrix, right? So अब इसको मैंने transpose किया. All the rows are becoming columns now. 2 minus 3 4 minus 3 5 minus 2 4 minus 2 1. Okay, so here we can clearly see that A transpose is exactly equal to A. Hence of course A is a symmetric matrix, and it is like opposite way also. Agar transpose is equal to that own matrix, then it is called a symmetric. Yeah, symmetric hai to it's like vice versa. Now the next is skew symmetric. Okay, symmetric ka thoda sa addition. It is thoda thoda like symmetric only, but what is the difference that I'll tell you is A is a skew symmetric matrix, then A transpose will be equal to minus A. Okay, अभी skew symmetric है तो जब हम लोग transpose ले लेते हैं, what happens is unlike symmetric में सब कुछ same होता था ना, inclusive the signs and everything, but skew symmetric में numbers same ही रहेंगे but sign सबका उल्टा रहेगा. अगर प्लस है तो माइनस रहेगा, माइनस है तो प्लस रहेगा. I'll give you an example. Suppose if we take something like this, 0 5 4 minus 5 0 minus 2 minus 4 2 0. When we take its transpose, okay, we're taking its transpose now, so this will be 0 5 4 0 5 4. I've written it like this, and this minus 5 0 minus 2 minus 5 0 minus 2. Now this one minus 4 2 0. Okay, yes. So now, so everything is the same, right? The numbers are all same. Zero cannot have negative or plus. Zero is just zero, right? So other than zeros, whatever numbers we have, यहाँ पे 5 है, we have minus 5. So all the numbers are same, but सबका sign change हुआ है transpose करने के बाद. So that is nothing but an example of skew symmetric matrix. Hence, this is A. This is your A transpose, but with change in sign. So A is equal to minus A transpose. Yeah, A transpose is equal to minus A. Both mean the same, right? Okay. So coming to the next property. Now, if A is a square matrix, okay? Square means of वहाँ जहाँ पे row और column same order का रहेगा. 2 cross 3 will not do. 3 cross 2 will not do. Like all 2 cross 2, 3 cross 3, 1 cross 1, 4 cross 4, so on and so forth. Where the number of rows and columns are all same. स्क्वायर जैसा दिखता है, ऑल साइड्स इक्वल, जैसे ये भी रोज एंड कॉलम्स इसमें इक्वल रहेगा. देन A plus A transpose is symmetric. The next one, A minus A transpose is skew symmetric. Okay, A is a square matrix, then A plus A transpose is symmetric, A minus A transpose is skew symmetric. Okay, so then we'll again taking an example question. Exam में they can give you any matrix, like A का कोई भी order का matrix they'll give you and they'll ask you check if this is true, yeah this is true, something like that, like they can ask you to tell. Suppose if A we're taking here is 3 2 3 5 4 8 7 minus 6 minus 5. So what do we want? We want to see ये proof करना ये है और ये है, right? We're checking these two. So A plus A transpose, A minus A transpose. So दोनों statements के लिए we need A we already have. We also need A transpose. So we will take A transpose. 3 5 7 goes like this. 2 4 minus 6 3 8 minus 5. Okay. Yes. Now the first one, A plus A transpose is symmetric. So let us find out A plus A transpose. What is A plus A transpose? Addition is always simple when it comes to matrices. It is just तुमको normally ये करना है. What do you call? Normally add करना है, element wise addition. So 3 plus 3, unlike multiplication, you have to work. पहले you have to check what is the order, like what is the you have to write it separately, पहला row with पहला column. But addition no problem, it's very very simple. It's just element wise addition. 3 plus 3 6, 5 plus 2 7, 7 plus 3 10, 2 plus 5 7, 4 plus 4 8. The next one 2 10 2 minus 10. Okay, these are the answers we have. Now this thing is clearly a symmetric matrix, as you all can see. अगर मैं इसका suppose क्या बोला था by the way, A plus A raised to O, A का transpose is symmetric, right? So A plus A transpose का matrix we have got, but this is of course symmetric. See हम लोग अगर इसको उल्टा भी करके लिखते हैं 6 7 10 6 7 एक्चुअली वो देख के पता चल जाता है, इधर भी 6 7 10 है, इधर भी 6 7 10 है, ऐसा 7 8 2 है, ऐसा 7 8 2 है. Here you have 10 2 minus 10, here also you have 10 2 minus 10. मतलब फर्स्ट रो फर्स्ट कॉलम जैसा है, second row second column जैसा क्या वही है, same to same, and then third row third column जैसा. So this is of course clearly symmetric. If you want to write and check that also you can do. 6 7 10 uh 7 8 2 10 2 minus 10. So of course, right, same. So this is symmetric. So therefore A plus A transpose is symmetric. Okay. Now the next one. What is the next one? The second one was A minus A transpose is skew symmetric, right? Just a second. The next one was A minus A transpose is skew symmetric. So this is A minus A transpose. We already have the value of A transpose with us. ये है A transpose. We're just going to minus whatever we get. I'll write. It's element wise subtraction only. This is what we get after subtracting. Minus 3, 0, minus 14, minus 4, 14, and 0. Now this is clearly skew symmetric. Skew symmetric means, as I said, ये property होता है, उसको transpose करके then everything changes with respect to sign. Plus becomes minus, minus becomes plus, everything. So यहाँ पे भी 0 3 4, यहाँ पे 0 3 4 but with all minus signs. Minus 3 0 minus 14. Here you have plus 3 0 plus 14, minus 4 14 0, plus 4 minus 14 0. So yes, of course, this is also skew symmetric. All right. Okay, so that is also done. Now, another property that you have, they've not given it as a separate property, just a point to note. We may prove it as in when we require it. Suppose a square matrix A, right? Any square matrix A, as I said, square matrix means equal number of rows and equal number of columns, can be expressed as the sum of a symmetric. They can ask you this as a blank or MCQ or one lines, I don't know if you have, and a skew symmetric matrix as follows. As follows. As follows means aisa wala. So any square matrix, suppose we have A, which can always be expressed as sum of symmetric and a skew symmetric matrix or something like this. So that is nothing but this property. This is again a property A plus A transpose plus half into A minus A transpose. So any square matrix can always be expressed like this. Okay. अच्छा हमेशा all the time we keep calling it as A या B something like that. But you know it can have any name. X Y Z P Q R S T can have any name. It's just that when we do it immediately वो A और B ही पहले आता है सबसे. Other than that, you know, you can have any names like that. Okay. Okay. So for example, if they ask you, they can give you a metric. Suppose abhi exercises may you have a few questions. The question is like this: express each of the following metrics as a sum of a symmetric and skew symmetric matrix. Then what you should do is you have to remember this formula, and then ये formula के according में you have to kind of bring the express the matrix. जैसे whatever matrix you have A है तो उसको ये वाले फॉर्म में लेना है. पहले A लिखो, A ट्रांसपोज लिखो, then A plus A transpose फाइंड करो, A minus A transpose फाइंड करो, then put it in this form. Then you can express that A as like this. Okay, so we will just take one solved example based on this. Suppose your A is if Your A given to you in the question is 4 minus 6, 7, minus 5, 2, 8, 3, 1, minus 9. Okay, fine. Of course, as we need A transpose, so we're finding out A transpose first. So A transpose is nothing but 4 minus 5, 3, like this, minus 6, 2, 1, 7, 8, minus 9. Now, of course, whatever things were there in the bracket, we'll deal with those first. हम लोग ये वाला bracket वाला first solve. See, वैसे देखा जाए तो this is like sum of two separate things, right? So you can consider this thing as one thing and this thing as one thing. Okay? ये plus के आगे जो है this is one, this is one. You can call it this as P, this is some Q. So let us just modify the terms first. A plus A transpose will be nothing but on adding the two, whatever we get, we are going to write down. So element wise, right? So this first, this one plus this one, then this one plus this one. We're going to do that. 4 plus 4 is 8. Minus 5 minus 6 is 11, minus 11. 3 plus 7, 10. This will be minus 11. 4, 9, 10, 9, minus 18. Okay, so that's your A. This is your A plus A transpose, right? So we have added. So as I said, what did we do? We are going to consider this. Even if you don't do it that way, it's also okay. But it's just that we are kind of modifying, and then इतना सारा लिखना नहीं पड़ेगा हमेशा half into A plus A transpose. So let us just assume we'll write it once. Let P be half into A plus A transpose. So this is A plus A transpose we already have. So that's nothing but half into A plus A transpose. What is A plus A transpose? This entire thing. 8 minus 1, 10, minus 7, 4, 9, 8, minus 11. Minus 11? Okay, is it minus 1? Minus 6 minus 5 is minus 11, right? Sometimes numbers only disappear. Anyways, so 8 minus 11, 10, minus 11, 4, 9, 10, 9, minus 18. So this is like dividing entire thing by half. So when you're dividing entire thing by half, what do you get? That k gets divided to each and every element inside. So 8 divided by 2, it's 4. 11 divided by 2. Instead of writing it in decimal, for time being you keep it as it is. 10 divided by 2, अगर divide होता है तो completely लिखो. No need to write it as 5.5 right now. We'll see it later on if we want to, divide. 10 divided by 2, 5. Minus, this is 11 by 2 again. 4 divided by 2 is 2. 9 divided by 2, 9 by 2. 10 divided by 2, 5. That's 9 by 2 again. That will be minus 9, right? Minus 18 by 2 is minus 9. Okay. So this is our matrix P now. So the matrix P is of course a symmetric matrix, right? 11 minus 2, 5. Either be 11 minus 2, 5. I've told you, you don't have to practically write all the time and see कि transpose निकाल के whether वो same to same match हो रहा है कि नहीं. This way also you can see. और वो देखो रो जो सेम है फर्स्ट रो 4 minus 11 by 2 5 कॉलम भी तो वही है 4 minus 11 by 2 5 तो अगर तुम लिखोगे तो भी वही आने वाला है so instead of by writing and wasting time when you can directly check whether it is symmetric or not. Next is minus 11 by 2 2 9 by 2. This is also minus 11 by 2 2 9 by 2 5 9 by 2 minus 9 5 9 by 2 minus 9. So we can clearly see that P is symmetric matrix, right? Yes. So P is a symmetric matrix. Now that statement that comes, right? P is a symmetric matrix. What was the initial statement? A should be expressed as sum of symmetric and asymmetric, right? So this P, ये जो हमने assume किया था, ये symmetric है. We have kind of proved, and now we are going to do the same thing, and we will assume this as some Q. Okay, the second bracket as some Q, और इसको we will prove that it will be a skew symmetric. So that will be symmetric plus skew symmetric. Suppose now the same thing, A minus A transpose. So let us do it quickly now. A minus A transpose, A also we have and A transpose also we have. So I'm just quickly subtracting because it's just normal subtraction. Okay, so this was A minus A transpose. So again you're taking now Q as some half into A minus A transpose. जैसे हमने P लिया था half into A plus A transpose, we'll take that Q as half into A minus A transpose. So your Q becomes this divided by 2. So 0 divided by 2 is 0. 1 divided by 2 is 1. Minus 4 divided by 2 is minus 2. Minus half 0 minus 7 by 2, 4 by 2 is 2, 7 by 2, and then 0. So likewise, you have all the other elements as well. Now we can clearly see that Q is an asymmetric, right? अब इसको भी लिख के check करना है तो you can of course check, but that's I would suggest don't do that. 0, half and minus 2. इधर भी देखो 0, half and minus 2 है, but all ulta signs, right? Here you have half 0, 7 by 2. Here also you have half 0, 7 by 2, all ulta signs. Likewise, the third one. So of course, Q is a skew symmetric. Skew symmetric में transpose होता है, और that sign is ulta. Skew symmetric matrix. Okay. So now A is expressed as sum of symmetric and we can't write. So A is now expressed as P plus Q. P was nothing but symmetric, and Q was nothing but skew symmetric. Okay. So thus we have expressed A as symmetric and Q sum of symmetric and skew symmetric matrices. So you have few such sums in the exercise also. We're expected to do in the same way. Okay. Now we have to move to elementary transformation. Okay. We're going to start with elementary transformation as I said. Now why do we need this elementary transformation? Is basically one major application is finding out inverse. Okay, so we will learn this and a few properties you have. With the help of those, we can easily find out inverse of matrix. Now suppose did I start? Yes. Okay, so suppose if you have none of the first property and then we can deal with the examples. Okay, interchange of any rows or any two columns. अभी elementary transformation जो होता है इसका major application is जैसे the one thing is to find out inverse, which we'll be doing it later. So there are three major elementary transformation of matrix which we are going to see one by one, which can be used both on rows and columns. Okay, so it can be done either on rows or on columns. The first one, interchange of any two rows or any two columns or any two columns. Okay, so if any number of row is changed या any column is changed, अभी हम लोग हमेशा the elements of matrices को in general we write it like this, right? Aij कोई भी element है. Suppose if this is the matrix you have 3 1 2 2 4 3 something like this. Suppose this is the first element that I have. So what is the position of this element? This element lies in the first row and the first column, right? So its position is actually AII. Sorry, A11, मतलब first row and first column. Suppose 4 है. 4 कहाँ पे lie करता है? Second column, sorry, second row and second column. So its position is A22. So that Aij in general we can write, which represents the position of the element which is in the ith row and jth column. I stands for the row number, J stands for the column number. Okay, suppose if I say A32, the element lies in the third row and the second column. If we interchange according to this property the ith row and the jth column of a matrix, then after the interchange, the original matrix is transformed to a new matrix. Suppose अगर मेरे पास कोई ith row है और उसको मैंने interchange किया with the jth row. Okay, So we can denote it using Rij like this. अभी ये वाला दो rows है. This is your first row 3 1 2. This is the second row that we have 2 4 3. मैंने R1 और R2 को interchange किया. Interchange means how will that look? Row 2 will go over here. Row 1 comes down. This is how R1 interchange R2 means. Okay, so the two rows are interchanged. Likewise, you can do the same thing for the this thing also, for columns also. Okay. Suppose columns के लिए अगर if we do, suppose A is 5 3 7 2, and we're now interchanging columns, that is C1 interchanging to C2. मतलब the columns are changed now. So 7 2 5 3. Okay, that's how it goes. Now the next property is, that was the first property, interchanging of any two rows or any two columns. Multiplication of the elements. Multiplication of the elements of any row or column by a non-zero scalar. So non-zero scalar means any number which is a non-zero number. Okay, scalar means any number. According to the condition, it has to be non-zero. Okay. Now, let us see an example. Suppose if any row Ri in general, okay, if any row, I'm just picking up Ri in general, is to be multiplied by a scalar. By a scalar, it's just that we denote it using k, like how constant complex c k denote करते हैं वैसे k से denote किया. Then we multiply every element of that row. Of that row means Ri that we have picked up. Multiply every element of Ri. Here is the case, Ri with that scalar. Suppose अगर तुम्हारे पास कोई एक ऐसा मैट्रिक्स है, something like this 1 2 3 2 5 0 4 1 3, and the operation that this is undergoing is 4R2. So what will this become? 4R2 means R2 is the second row. So second row को only you are multiplying with 4. So that doesn't mean कि सिर्फ 2 को 4 से multiply करना है या सिर्फ 5 को 2 से multiply करना है. All the elements of the second row will get multiplied with 4. That is 2 4s are 8, 5 4s are 20, 0 into 4 is 0. And the row 1, row 3 will remain unchanged. It will be as it is. This is 1 2 3, this is 4 1 3 as it is. Likewise, of course, for the column also the same thing happens. अगर column के लिए यहाँ पे suppose C3 किया है, 3 into C3, then this becomes 9 0 9. The first two columns will remain absolutely unchanged. I suppose we can understand the same property for a row. Column के लिए you can easily understand because it's very similar. Now the last one. Adding the scalar multiple of the scalar multiple of all elements of any row or column to corresponding elements of any other row or column. So ये जो bracket में लिखा है, that means row या फिर column के लिए the same rules applies. So that is like writing row slash column. मतलब जो भी row के लिए apply होता है, the same property will apply to the column also. So what do you mean by this? Adding scalar multiples of all the elements of any row or column to the corresponding elements of any other row. जैसे कि अभी if we have some ith row. Okay, कोई तो ith row है and some jth row also if we have. जैसे second row है and third row if we have. So what we can do is any multiple जो हमने third row के साथ multiply किया, we can always add to the any other row. Like जैसे अभी ऊपर वाला example we saw, we multiplied, right? ये 4r2 किया है. Next step में we can also have something like r1 plus 4r2. So that r1 becomes 1 plus 8, 2 plus 20, 3 plus 0. So that will be written like r1 plus 4 times r2. So we'll see an example. If you have a as we have a like this 2, 5, 7, 8, then what will be your r2 plus 2 times r1? R2 plus 2 times R1 is nothing but here we can clearly see that R1 is getting